Welcome back to RamZland. We're learning about buoyancy today, and our first demonstration here is with raisins and 7-Up. And you can see that raisins typically will sink in 7-Up until something happens and they start to float. Do you see those bubbles that are attaching to the raisins there, Hansla? Mm-hmm. Pretty soon, I think there'll be enough bubbles to make the raisin float. There it goes. And then it sinks. Fred, why do you think the raisin sinks after a minute?
Because the bubbles pop or they float back up.
The bubbles pop. That's exactly right. I see that happening too. Now, Gift and Gabby over here, I did another demonstration with what's called a Cartesian Diver, and does this one still work?
It went all the way down.
Did that one dive and that one dove?
No.
Okay. And the Cartesian Diver works by having a dropper inside that's partially filled with water. Could you do that again, Gift? So, Gift, in this one, the dropper is positively buoyant when it's at the top, but why does the dropper dive like that, Gift? What's happening to it?
Because it goes down because the pressure pushes it down. And
what goes into the dropper when you squeeze it?
Water.
Oh, so go ahead and give it a squeeze. Okay, so the water is forced inside the dropper when you squeeze it. It has nowhere else to go, does it? And that increases its density and it starts to dive. Very cool. Good job, table 2. Hansla, Fred, way to go. And here we are with table 1, and we're learning about buoyancy. And I see you've got the 7-Up and the raisins ready to go. Do you have some raisins that are getting some bubbles on them?
That one and that one.
Oh, yeah, I see them.
One of them was floating, but it is.
Here it goes. That's cool. Now, Amaya, why does the raisin become positively buoyant? Why does it go to the surface like that?
Because of the bubbles, and when the bubbles go onto it, it creates air, so it goes up.
Okay. And why, Greg, why do the raisins sink after they get to the surface? Why does it go back down?
Because the bubbles pop.
Oh, they pop when it reaches the surface. That's cool. Now, there's another way we can illustrate buoyancy, and that's with the Cartesian Diver. So, Amaya, can you make the dropper inside there go down? Yes, there it goes. And this is kind of like a submarine, isn't it? Kind of like the ballast tanks of a submarine. Why does the dropper dive?
Because of the water in it.
Oh, so when you squeeze it, it forces a little bit of water inside there. And then when you let go, that little air bubble squirts it back out, doesn't it? Very cool. Good job. Here we are with table 4, and they are demonstrating buoyancy. Medina, it looks like you've got some 7-Up and some raisins there. And I see some of them are getting some bubbles. That one's moving a little bit. Medina, why does the raisin go to the surface like that? Why does it do that? What's happening to those raisins on the bottom? Something's sticking to them.
The bubbles are sticking to it.
Yeah, it's attracting some of that carbon dioxide from the pop, and it's sticking to the raisin. And maybe when they have enough bubbles, they float up. That's right. And when they get to the surface like that one, why do they go back down again?
Because the bubbles pop.
The bubbles pop, that's right. So you guys have another device there that can kind of demonstrate neutral and negative buoyancy, and this is like a submarine, and it's called a Cartesian Diver. And Mason Smith, can you make your little diver dive? Can you make it go down? Yeah, there it goes. And then it goes back up again. Can you tell me why does the dropper go down? Cameron, why does it go down when Mason squeezes the bottle? What causes it to dive like that?
The water.
Okay. Squeeze it again, Mason. Where does the water go when he squeezes it?
Inside it.
It goes inside the dropper. And you can see the water level in the dropper go up just a little bit. And that makes it heavier, doesn't it? heavy enough to dive. Good job, table 4. Here we are with table 5, and they are learning about buoyancy today with raisins and 7-Up. Let's look at some of your raisins. Oh, that one's floating for just a minute, and then what does it do?
It goes back down.
It does, it goes back down. Jiley, can you describe to me what makes that raisin want to float?
The bubbles that go up, and then when they pop, it goes down.
Okay, so it becomes negatively buoyant when they pop on the surface. Oh, I saw one pop. You're absolutely right. And then Mason Crowley, once it goes back down again, it starts to build up what? It starts to get more...
Bubbles.
Yeah, it does. It looks like it gets more bubbles as it goes back down to the bottom. Now, there's another way you can demonstrate buoyancy, and that's with a dropper in a 2-liter bottle. This is called a Cartesian Diver. Mason Crowley, would you squeeze that bottle and see what happens to that dropper inside? Oh, it goes down. Can you make it neutral buoyant so it just stays in the middle? Oh, that's cool. So when he squeezes the bottle, why does the dropper go down? Why does it go down?
The reason it goes down is because the water, it keeps on building up. And whenever it goes down, it makes it heavier.
It does make it heavier. So when he squeezes the bottle, the water is forced where? It's forced, where's the water forced? Yeah, into the dropper. You can actually see the water level rise a little bit when he squeezes it, can't you? Mm-hmm. Now this is a tricky question. What makes the water go back out of the dropper? When he stops squeezing it, why does the water go out of the dropper so that it becomes positively buoyant? Have you thought about that?
You're not putting pressure?
You're not putting pressure on the outside of the bottle, but what's at the top of the dropper?
Air.
There's air at the top of the dropper, and so that air is a little less pressurized when he lets go, and it pushes the water out, doesn't it? Just air pressure pushes the water out, like the ballast tank on a submarine. Good job. Here we are with table 3, and what do you have in your flask here? What is that?
Raisins.
That's a raisin? And what's filling the flask? What's in the flask other than Sprite? Okay. Why does the raisin start to float after a while? Why does it do that? There it bubbles? Yep, look at that one. There it goes.
It's mine. The bubbles make it float.
Now, Jada, if the bubbles make it float, why does it sink after a little bit? Why does it go back down? Because now it's...
Because the bubbles pop.
The bubbles pop. So for a while, it'll become positively buoyant if it gets enough bubbles, like that little one. But if they start to pop, then it dives. Now we have another experiment that demonstrates negative and positive buoyancy that you have, Mahalit, and that's called a Cartesian Diver. And it looks like you made that with a dropper and a little hex nut to give it some weight and a 2-liter bottle. Can you make that dropper dive? Give it a good squeeze. There it goes. And now it's at the bottom, and then when you let up, it goes back to the top. So Mahalit, when you squeeze the bottle, why does the dropper go down? What's happening when you squeeze it like that? Is something going inside the dropper? Making it heavy?
The water.
Yeah, so if you squeeze the bottle and the lid's on tight, the water has nowhere to go but into the dropper. That increases its density and it dives. And then when you stop squeezing it, that little air bubble on top, it pushes the water back out again and it becomes positively buoyant. That's called a Cartesian Diver. Good job, Mahalit. And 7-Up with crazy little raisins. Look at those little raisins. Good job. Way to go, table 3. Here we are with table 6. They're learning about buoyancy today. And you guys have a flask filled with 7-Up. And there are raisins at the bottom. And we want to see raisins that become positively buoyant and then slowly negatively buoyant. And even some are neutral buoyant for a few moments in the middle, like that one right there. Chase, what makes the raisin want to float? Why does the raisin float for a while?
Bubbles.
Yeah, there are some bubbles on that raisin. And then, Isaac, why does the raisin sink after a while?
Because once the bubble gets to the top, once the raisin gets to the top, the bubbles pop.
The bubbles start to pop, don't they? And then it dives, it becomes negatively buoyant. Now, you guys also have a Cartesian Diver over here that illustrates buoyancy. What happens when you squeeze the bottle, Chase?
It goes down.
It does, it dives. And you can even make it neutral buoyant. You can have a hover in the middle. Chase, what causes it to dive like that?
Whenever you squeeze it, it puts pressure and water goes in it.
Water goes into the dropper. And that makes it, does that make it heavier or lighter when water goes into the dropper?
Heavier.
Yeah, it increases its density and it starts to dive. Now, Melody, what makes the dropper want to go back up to the surface?
The buoyancy.
Okay, it becomes more buoyant.
It's positively more.
Whenever you let go, it releases some of the.
Because when it goes down, it adds water. You can see that it kind of adds water.
Uh-huh.
And then when you go back up, it releases the water and goes back to the top.
Okay, so the water goes out of the dropper as it rises. Melody, what pushes the water out of the dropper? What else is in that dropper other than water? What else is inside that dropper at the top? Yeah, there's a little bit of gas inside the dropper, and so if you squeeze it, the gas is under pressure. If you let go, that pressurized gas pushes the water back out again, making it less dense and more buoyant. Good job, table 6, learning about buoyancy.